Happy Friday. In this video, I'm going to be talking about Bayesian optimization for AI security. I can explain what is Bayesian optimization and how is it relevant in terms of detecting threats, AI threats in cybersecurity. One word of caution, Bayesian optimization is one of the more technical parts in mathematics. So I tried to find other people that they have explained it easier, and I started feeling sleepy just by watching those videos. So this is just a warning. I'm going to try to explain it without using the mathematical formulas and these difficult graphs. Because if you watch any of these videos on Bayesian optimization, good luck to you. After like few seconds, you're gonna lose the plots. And if you work in AI security, the only thing that you need to know is how this Bayesian optimization is relevant towards AI security. You don't need to know the mathematical details. You can leave that to people who study physics and people who study, natural sciences or other areas. Now, this is part of a series that I'm recording on YouTube in preparation for my course on AI malware analysis, which is with O'Reilly. And this is going to happen on 3rd of January. Depending when you watch this video, you might still have time to register, but maybe you're going to watch this long after the course is finished. Most large corporations and universities, they have free subscription to O'Reilly Digital Library, so you might be able to attend the course without actually any fee payment. This is the segments that I'm going to be doing. So I have 8 segments in the course, and what I'm going to be teaching today, the Bayesian optimization, is going to be one of those segments. And here's the catch: YouTube is the YouTube channel that I have is for free, and it's never going to have any payments or membership associated. If you subscribe to this channel, you're going to be getting these videos as I prepare for the actual course. So they're going to be small sections of, let's say, half an hour, 15 minutes, maximum 40 minutes, and I'm going to be explaining those technical terms. Some people actually prefer that than to attend a 4-hour long session, which is going to be exhausting. Actually, there's some studies that show that human brain can only accumulate up to 20 minutes of this kind of a technical knowledge. After 20 minutes, you start getting tired. So if you're interested in this kind of content, please subscribe to my YouTube channel. It's going to help motivate me to keep the channel going. And I believe in free education. So the purpose of the YouTube channel is to share the knowledge for free with the entire world, regardless of where you are, on which continent, in Africa, Alaska, or wherever, you're going to be able to learn how Bayesian optimization works in terms of AI security. Other topics that I have covered in the channel, as you can see, yesterday I spoke about static analysis with Snook, that's analyzing reverse engineering polymorphic malware. So I have another polymorphic malware video with Black Mamba, and there's various other videos. I'm going to be covering Snook is what I covered yesterday. Tomorrow I'm going to be covering hybrid analysis. Black Mamba I already covered. This is a polymorphic malware. Guidra, I'm going to be covering Guidra in a lot more detail. Guidra is reverse engineering software. But today, so let me close those so they don't confuse me. Those are for future videos to keep you attracted and hopefully to get you interested to subscribe to the channel. And if you prefer more lightweight, in content, you can subscribe to my cryptocurrency channel where I'm teaching people how to test new projects and get free crypto for free. Remember, most of the cryptocurrencies at the beginning, they were free. BTC, I received a lot of BTC for free. I sold them for around 100 British pounds, and I went out on a night out. That was many, many years ago. Then I received Ethereum, and people say, yeah, that was the biggest mistake. Not really. I received loads of airdrops afterwards that I sold. So if BTC was a mistake, I made many mistakes. And you can make many mistakes as well. So you can subscribe to this channel, and I'm going to show you how to test new projects and get free cryptocurrencies just for using the project. But having to said that, I'm closing those 2 channels. So I can keep this one open, so I'll come back to it. And for the Bayesian optimization, I said I'm going to try to explain it without the use of these mathematical formulas. And for that, I can use a whiteboard. So I'm going to switch off from this computer and I'm going to move to the iPad now where I can draw and explain to you with drawings how Bayesian optimization is relevant for AI security. For this section of the video and how to explain how Bayesian optimization works in terms of AI, I'm going to use Freeform, which is the Apple native version of a whiteboard. And for that, I have a few images that I'm going to use. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 images in total. So it's not going to be that long, but there's quite a few things that we need to cover with the Bayesian optimization. And this is why sometimes it's much easier to explain things in a formula than to go through 9 different figures. But just as a reminder, the purpose of this video is Bayesian optimization for AI malware analysis and how to improve threat detection. So this is a very specific aspect of Bayesian optimization. It can be used for various different reasons. It's a mathematical thing, right? Starting with the first one, to understand Bayesian optimization, what is it? Well, Bayesian optimization is just a statistical approach. It's usually employed for optimizing very complex and computationally extensive functions. That's what is highly relevant for AI-driven malware analysis and threat detection. And how it works? It works by building a probabilistic model of the objective function, and then you use this model to identify the most promising area to evaluate next. So this methodology is useful in scenarios when you involve AI malware because it enables security teams to fine-tune detection models and to also automate feature selection, to optimize hyperparameters in machine learning pipelines, and to counteract evasive and polymorphic threats. So in this section, we're going to go into a step-by-step explanation of how Bayesian optimization can be implemented to enhance AI malware analysis and how to improve threat detection. So step by step, I mean for every diagram, I'm going to have a step, and then it's going to be another one, and then I'm going to be drawing to explain how those specific processes would work. So if you stay with me until the end, I promise that I'm not going to use not even one formula. And by the end of this video, you're gonna know what is Bayesian optimization, which many people struggle. Some people even finish their degrees without learning what is a Bayesian optimization. So first step is that the Bayesian optimization uses a surrogate model. And this surrogate model is often a Bayesian process. Usually it's written just GP, and in some of the slides it's going to be written like that, just like GP. GP like your GP doctor, but it stands for Bayesian process. And for this step, the Bayesian process is there to approximate the objective function and to calculate the acquisition function to decide where to sample next. For malware analysis, the objective function might represent metrics such as detection accuracy, precision, or recall of a machine learning model. So by interactively updating the surrogate model with new data points, Bayesian optimization effectively narrows down the hyperparameter space or feature set to maximize the desired outcome. So I hope that part is clear so far. So what is the key point here? From the surrogate model and the data point, to narrow down the hyperparameter space or the feature set to maximize the desired outcome. So that's if you didn't get anything so far, that is the key. So that's the whole purpose of why we use Bayesian model. What are the key components that you would apply here? Well, first you have the objective function, which we said, then you have the surrogate model, and then you have the acquisition function. Those are the 3 steps that are required. And the objective function defines what is being optimized, such as the model accuracy or the detection efficiency. The surrogate model, it's simply a probabilistic optimization of the objective function. Typically, this is using Bayesian process or T-structured Parsen estimates, which is written as TPE, and it stands for Tree-Structured Parsen Estimator. And third step is the acquisition function, which gives you the sampling point by balancing exploration, the discovery of unknown areas, and exploitation, focusing on the promising areas. So those are the three steps over here. And in terms of in terms of implementing the Bayesian optimization in malware, let me see. We have another slide. Okay, this is quick. We're moving on to a different slide already. And for implementing the Bayesian function in optimization in the malware analysis, first you need to define the objective function by establishing a measurable goal for malware analysis, such as maximizing detection accuracy or minimizing false positives. Then why is this important? It's important because the objective function serves as a foundation for optimization. And this is how you determine what the Bayesian process is trying to improve. And here's the key thing, how to complete. Well, first is that you would use a malware detection model such as a random forest or gradient boosting, and you would define the detection metrics. And usually that is done with AUC or ROC. And that's area under curve, and ROC, it was something over curve. So that's what it stands for, area under curve. And that's the objective. And the second step is to incorporate the evaluation pipeline for AI malware. And this is focusing on identifying dynamic and polymorphic malware behaviors. So this is where slowly moving into more focused from mathematics into polymorphic malware. And to select the surrogate model, how do you select the surrogate model? Well, you need to choose a probabilistic model that approximates the objective function efficiently. And this step, why is it important? Because the surrogate model enables Bayesian optimization to predict objective function values without exhaustive sampling. And key step here is how do you complete this? Well, first is you implement the Bayesian process, the surrogate model for a smooth objective function. Second is for high dimensional feature spaces or non-smooth functions such as TPE or Bayesian neural networks. And third would be you would need to include prior knowledge about malware behavior patterns such as API call sequences or obfuscation techniques or call mutation rates. And again, why do you need API? Because remember that polymorphic malware needs to connect to API in order to change its code. So API would connect the polymorphic malware to some generative transformer model like the OpenAI or Chat GPT or any other transformer model, and then that would send via the API would send the message back to the polymorphic malware and it would change the code. So this is where you can catch it because it has to communicate with the API. Now moving on with the third one, how to configure the hyperparameter search space. Here, what is the objective? The objective is to define the range of hyperparameters or features to optimize. And why is this important? Because narrowing down the search space ensures that efficient optimization can be ensured and maintain the same throughout coverage. Now, here is the more technical aspect here, how to complete. Well, first you need to identify the hyperparameters which are critical for malware detection, such as the learning rate, the number of estimators, or feature selection threshold. And second is you need to specify ranges or distribution for each hyperparameter. For example, the learning rate, if it's 0.001 or 0.1, then you would need to have the number of estimators, which could be, for example, 50 or 300. And that is what the specific ranges that you need to identify. And for the hyperparameter here, you need to have learning rate, number of estimations, or feature selection thresholds. Now, going out to the another slide, which this is probably slide 4 out of 6 or 7 in total. How do you initialize the optimization process? So first, what is the objective of initializing the optimization process? You need to generate initial points for sampling based on the surrogate model. And why is this important? It's important because it provides a baseline for the Bayesian process to build the surrogate model. And how do you complete this? Well, you can use hypercube sampling, Latin hypercube sampling, which is LHS, or SOBO sequences. To generate diverse input points. So that's the first step. And second, you would need to evaluate the objective function for these points using a trained dataset of known malware samples. So, and there's loads of trained datasets of known malware samples. And this is the step number 5, I think. How do you use the acquisition function to guide sampling? So what is the objective of this? Why do you need to do that? Well, it's to balance exploration of the search space and exploitation of promising areas. And why is this important? Because it's important because it ensures that the optimization process efficiently discovers the best performing hyperparameter or feature sets. And then how do you complete that? First step would be to implement the expected improvement or upper confidence bound acquisition function. And the second step would be to use the acquisition function to select the next set of hyperparameters or features to evaluate. And now we're going to be moving to the 6th point. And hopefully you're still with me because we are getting closer to the end and then we're going to have a conclusion. And this is the 6th step, I believe, to evaluate and update the surrogate model. Why do you need to do that? You need to do that because you need to incorporate new data points into the surrogate model to refine its prediction. And why is it important? It's important because the surrogate model needs to improve with each interaction. So that would enable more accurate optimization. And how do you complete that? First step is you would train the surrogate model with updated datasets, and that includes new and evaluated points. And second step would be to recompute the acquisition function to identify the next sampling point. Now, this is the 7th diagram that I have, and the last one, the next one, is one more, but that's the conclusion diagram. So to analyze the results and deploy the optimized method, why is it important? What's the objective of this step? Well, this step would finalize the optimization process and implement the improved malware detection model. And how do you achieve that? You would deploy the optimized model, enhancing the threat detection capabilities. But how to complete? What are the specific steps that you need to do? You would use the optimized hyperparameters or features to train the final malware detection. That's the first step. And the second step would be to validate the model using a test data set containing advanced AI malware samples. And the third step would be to deploy the model in a real-world environment and to monitor its performance using metrics like precision, recall, and F1 score. Now moving to the final slide, which is, let's see, no, this is the final slide. So this is the concluding slide. And what are the practical implications of Bayesian optimization in malware analysis? Well, the first one is that you feature selection for malware detection. And here you have two different key elements to remember. First one is that Bayesian optimization can identify the most relevant features, such as the API call patterns, opcode sequences, or file metadata for detecting AI-powered malware. So that's the first one. And the second one is just an example. So you can select the top 10 features from a pool of 1,000 that maximize the detection accuracy. So this is how you would be able to complete this step. So you select the top 10 features from many features that you would be able to find. And so the second point to remember that is that optimizing hyperparameters of AI models. Here you have again two sections. So let me zoom in a little bit so I can write. First is that fine-tuning machine models such as neural networks or random forest. With this you can improve the detection of polymorphic malware. And what is an example of to achieve that is you can adjust the number of layers and neurons in deep learning models to balance the accuracy and computational efficiency. So first we have why and how do you need to do it, what's the purpose, and second is how to do it. Now moving on to the third thing that you have to remember is the dynamic malware behavior. And here again we're going to have one which is going to justify what it is, and second example of how you can achieve it. Well, why do you need to have dynamic malware behavior analysis? You need it because you need to identify optimal configuration for sandbox environments to capture dynamic behavior of polymorphic malware. And how do you achieve that? You can achieve that by configuring memory and CPU constraints to mimic target environments. And the fourth and the final is the real-time threat detection. So for here we have also explanation why and then an example of how you can achieve that. So why do you need real-time threat detection? You need it because you can use Bayesian optimization to adjust the detection threshold dynamically and based on the evolving malware behavior. So the malware is going to change. Polymorphic malware is going to keep changing. So it looks like this, and then in the next iteration is going to look very different to the AI. So you need to constantly adjust the detection threshold. And how do you achieve this? You would set adaptive threshold for anomaly detection models in high traffic networks. And final note before we end this video, so let me zoom out and see, did we cover all of them? Yes, we have covered all 9. Final note, Bayesian optimization, it's a useful tool and it's a framework for enhancing AI malware analysis and threat detection. It's free. Nobody owns Bayesian optimization. It's just a mathematical formula, right? And everybody can use it. That's why we use it in the research a lot, as opposed to some of the other techniques that I'm going to show you that they come with licensing fees. So by effectively exploring complex hyperparameter spaces and refining feature selection processes with Bayesian optimization, you would be able to develop highly accurate and scalable detection models. So you can do this on your own. You don't need to pay licensings. The methodology that I outlined in this tutorial demonstrates how the Bayesian principles can be applied to counteract sophisticated AI-driven malware, ensuring that the threat detection system remains effective in an evolving threat landscape. But having said that and explained it all beautifully, you know that if you work for another organization, there's a framework, and usually they're going to say you can do this and you cannot do that, and Bayesian optimization usually is going to come outside of that box, and usually inside you're going to have something like Snook, which is already commercial software, and you're going to have to use that, unfortunately. So we use it in research, and I think it's a very powerful tool, but it's not necessarily the best tool for you if your organization won't appreciate the time and the effort that you need to put in to run this and to build this model. But in the next video, I'm going to be talking about, actually I have a video on Snook, so you can watch those videos. In the next few videos, I'm going to be talking about various other techniques. Actually, I have 8 segments, so this would be the segment for the segment 9. Bayesian optimization is for segment 9. For each one of those segments, I'm going to use a different example in my course. I'm starting to lose my voice, so I'm going to stop this video and I'll see you in the next one.